Okay, guys, welcome back. My name is Sal Cosentino. I'm your cloud architect, trainer, future MCT. Today is 26th, 2025. In today's topic, I want to talk about a few things that I think that are important. Something that comes up a lot when you're designing your systems, in Azure and even your on-premises systems, that a lot of people still get confused. And typically it's when your virtual machines are designed. Your virtual machines, sometimes need one or two virtual CPUs under specific requirements and conditions. And it's important to note that when you're doing this, you follow the correct guidelines and conditions, and not get them confused. Sometimes it's best to follow vendor documentation, right? Um, and guidelines, especially when you talk about high workload, um, performance, right? These are some important, and this is in terms of requirements and conditions, right? Especially in our labs when we're creating these specific machines, right? This is a test environment. By all means, it can be your own environment if you want it to be. You know, if you believe in what you want, you can succeed and get to where you want to go. Um, I'm just going to, okay. So, let's talk about these virtual machines and how they're being designed, and you see me create machines day in and day out, and you know what's behind the scene, and how do you know um how do these machines function, and what environments they need, and how they work for specific applications, and how those are designed, right? So it is important to understand. So when we're talking about high workload performance, we talk about applications that are CPU. Um, oh, what does that mean? Well, if you're using or running software that requires a lot of CPU, what software requires a lot of CPU? Any video encoding, any simulations that you're running, any high intense application software, like data analysis, that software requires two or more vCPUs to help, right? And I think I brought this up in some of my classes, and I'm going to bring this up again. When you're creating these virtual machines, type 2 or type 1 hypervisor, same concept. You're looking at the number of processors and the number of cores per processor, right? And that'll accumulate to your total. We want to understand the difference between the two processor at each one core per processor versus the one processor at two core per processor, right? So, for a home lab, my best practice is one processor and two cores per processor, or even 1 to 4 cores, right? 2 to 4 is my main goal, right? So 2 processors means that obviously when we're talking about license, but we're not talking about licensing right now. We're just giving an example of processor configuration, right? And we'll go into the basics of your physical machines and how your physical servers work, right? And for example, here's a server, right? And I'm going to post this here. Right? So here's an example of a physical server, right? Right? So that's your physical server, and we could say that in this physical server, you have 2 sockets or processors, let's say, at a total of 16 cores uh, per socket, right? And again, socket is your processor, so that'll amount to 32 cores total. Um, when we look at a virtualization, it all depends on your server and what your server can handle and how many machines you can add into your processor. And I can go on forever and talk about different processor speeds and different machines and types. And, we can talk about that forever. But, when we're talking about that, I like to, use this equation. Your total physical cores equals your number of sockets, right? Which is what we talked about already. We know that your sockets are processors times multiplied or times your cores per socket or processor, right? So processor and sockets are the same thing. Just remember that. Where your total logical processors in a virtual environment, and logical is a virtual environment, right? Are your total physical cores times your threads per core, right? Just remember, when we talked about hyperthreading in some of my other classes, hyperthreading is, divided by 2, right? So it splits it in half. When we look at our diagram here, right? Actually, let me duplicate this a few more times. Right. And when we look at, a processor, 2 processors times 1 processor, we have a remaining cores and cores left inside each processor, right? So if you have 2 processors total, you have 1 core per processor, right? You have 15 cores left in each processor, right? So, you have 15 in this one and then 15 in this one, right? So that'll give you a total of 32 or 30 remaining cores, right? When you have your 1 processor, you have a total of 2 cores, which means that we have 14 cores remaining. And it's really simple math. As long as you follow the equations and the guidelines, you'll be on your merry way. Um, right. When we're talking about, uh, how they're designed. We look at high workload performance as architects. Are these applications CPU bound applications, right? And this is in our lab, right? So this is created in our lab. This will be created in our lab, right? Our virtual machines or VMs might need two virtual CPUs, right? Or more, um, as long as these conditions are met, right? And I'm gonna tell you three conditions for now. There's many more, but what I want you to know are these three, and these three are important when we talk about the applications that are CPU bound. If we're running software that requires a lot of CPU, um, two or more vCPUs would help. And that's the scenario that we want, right? So in an example, we can say, I've seen a lot of IE video encoding software, right? If you're creating a machine, make sure you have two vCPUs minimal to have that met for performance. Sometimes I've seen simulation machines, right? Or even data analysis machines, right? So these are some sort of examples that I've seen when we're talking about applications that require two CPU or more. Another example, our second example, we're looking at web or application servers, right? And again, that's just to moderate how intensive and how much data is coming in and out between often as possible um, within these web servers or application servers, which will benefit from your 2+ vCPUs, right? So especially if we need to handle like concurrent requests that need to occur, right? So concurrent requests, right? This is where we're going to need our 2 plus vCPU. And lastly, concurrent requests, right? And busy servers, right? So like, I can say like, you know, like an e-commerce site that's constantly being used a lot in this web server that requires you to use a credit card, and people are going into the marketplace, like Amazon Marketplace, for example, right? I could see that being busy where that might need a lot, way more. But I'm saying like with a store of like two or three items, for example, right? And then there's Shopify, right? Shopify, which is a cool one. Some examples, right? Like there's other web and application servers that you can use, right? To denote that. And then lastly, and our third condition are database servers, right? And again, database servers benefit from multiple vCPUs, right? And we need to basically, and this is more for like querying or just concurrency. And we have some databases that I've seen in an example, i.e., MySQL, right? Or even PostgreSQL or TSQL or something like along the lines, or even Oracle based SQL servers applications. And if we look at some examples of database servers, off the top of my head, I have a list. Um, I have a list here of 9 different types, which is perfect example. I'm going to give that to you guys in just a second. So I will show you guys some examples that I've gotten for you. And this is very important. And here's some database. All right. And example. Okay. So here's some database server examples. You know, you have your obviously Microsoft SQL Server, top of the list. You know, you have you know, a database server is typically your a server where you use a database application and that provides those DB services to other programs that are on your computer or just the computers in general, right? And when we're talking about the design of a database server, right? We look at, you know, your clients and, you know, um, are they standalones? Are they client applications? Like, for example, here's an example of something that I can show you guys. Copy the image, and I want to show you guys an example of a SQL Server web application. Oh, I'm going to duplicate this, and this is a good example. Here you go. So, you know, here's an SQL functional diagram, simplified diagram where the SQL server within, well, you have your web browser, internet facing or web facing um, application. Sorry, internet, right? And then you have your firewall, and then between your firewall and your web server inside are created by an intranet. Um, right? And these systems are web facing systems, right? So they need to know um, if the recipient, they need to know if there's a recipient to where, um, how to explain this to you? So they need to know if there's a recipient to where they send their traffic to, or if they would send their data, right? So simplified, you know, you have a DNS that just can't assume that these machines are available. Um, you know, and we need to send some form of health check, um, you know, or some sort of listener um, for you, for example, when you're logging into that specific site and determine where we're going to send that web server, right? Within our data center or our cloud environments as well too, right? So like Cloudflare, AWS, Azure, Oracle, Microsoft, obviously Azure, um, and so forth. Um, in this diagram, it shows you how, you know, we can use an application server, right, with and our SQL Server Management Studio, um, and then access that data layer from your intranet, right? And in that secure web application, you know, we have our security, our query processors, and our SQL common language runtimes, our Windows Server system, and on top of that is our secure. And then we have our storage management, right, where we have our tables, our disks, our direct connection, where we have an internal server bus. Then we have a tables within our storage. for network storage, disks, and other storage like files in cloud, right? So that's something similar when we're building that high performance machine and a high workload machine. There's a lot of high workload, as you can see in this machine. So it requires a lot of, we can create policies that, you know, that say that or send 80% of the traffic to the data center or send 100% of the traffic to the data center. But if we can reach a certain level of latency or just even a performance we can start scaling out or even add capacity to our AWS or Azure just to make up for that lack of capacity. It's something called cloud bursting, but I'm not going to talk about that too much, right? Just again, we need to be able to auto scale these web servers and just for increase of availability and performance, right? So, we need to make sure we have these resources available, right? And especially in auto scaling on these web servers or containers, right? Where we're serving containers serving the web, where we can add capacity and then have that up and running within a few minutes, or even as an example, 20 minutes or so, up to its full capacity, right? To its cloud providers or even just your on-premises data center, right? So it's important to note that these are some database servers examples that we can use. And again, please familiar yourself with these. These are some sources that are typical in what it's used for and how it works, right? I can create a database course, in the future, but for now, again, you have your web server, um, you know. So if I were to draw this out, let's see, I can draw this out, right? So we have your web server, right, and then you have your application server, and then you have your database server, right? So we have to understand the differences between the two and how you know if we were to firstly it often gets confused, right? So you have your server, and even just to know what a server is um and what a software is also important, right? So know the difference between a software, right, which is a logical, right? So it's logical, whereas versus a server is physical, right? So understand that the differences between the two are important when you're talking about these, are confusing yourself with this, right? So, you know, there are in a web application, right? In a web application, um, it consists of a web server, right? An application server and a database server, right? Right. So I'm denoting the three. So you have your web application, right? Then you have your, and this is without networking. This is without security, and this is just in general. Um, because it is important to note the differences, because if you're not understanding the differences and what they mean, you might get it confused, right? So I don't want to confuse anybody here, and you guys should not be confused when you're going into these interviews and you're explaining these things, because uh, you have to understand that this is a question that's asked, right? Like when you host a website and you had an HTTPS login to like the control panel of a website, right? And then you put all your folders in your HT docs, and then there were there weren't those three separate things, right? So there was no web server or application server. It was just you had that HTTP, you went into the control panel, you put all your files in htdocs, right? I don't know if you guys remember htdocs, right? This was back in the days. Um and this is where, you know, it was like that. But again, like you have to kind of see where everything um evolves in our future, right? And how things change. Um, so you have your web applications, you have your server, your application, or your web application, or your web server. Sorry, server, web server. You also have your application server, app server, and then you'll have your database server, right? So lastly, your database server, right? So these are the three um, machines. It does get confusing. It often gets confused, but again, in a web application, it consists of inside your web application. So if we were to box this inside your web application, just so that we're not, uh, and this is your web application to simplify web application, right? You have your web server, your app server, and okay. Um, this is a common misconception. It gets confusing. A lot of people do get confused with that stuff. So, first thing, server, is logical. I'm sorry, server is physical. Your software is a logical piece of software, right? So it's important to note that when we talk about our web or application, and our database server software, it can all run on the same physical server machine, right? So, or distributed across multiple physical machines, right? So a lot of the most large websites will have multiple machines, um, right? You have multiple machines, right? Within um, within those websites, right? Right. So this could be on within a website. Um, Right, in architecture, we come up with multi three-tiered application approach and architectures, and how those work. That's a totally different topic. But again, just understand that it can all be run on a physical server machine, or just across multiple physical machines, right? Or obviously now when we're talking about our VMs, it can run across multiple VMs. A lot of the larger websites have multiple machines, as you can see, the larger websites, right? You'll have multiple machines, where most consumers will host packages, right, that are run on that single box itself. So you can have one box with multiple machines on it, right? Or hypervisors on your hypervisor. The web server deals with the HTTP requests. Um, So, those HTTP, and then it'll just request, and then passes those requests to the handlers. And then they'll have built-in handlers for file requests, like your HTML pages, your images, your CSS, your JavaScript, stuff like that, right? And again, additionally, those handlers for requests that they can't manage anymore. Like, for example, you have a dynamic page that's kind of delivered by your application server. Then you can have web servers that implement HTTP specification and know how to manage those requests and response headers, right? And that's just in a web web server, right? And then your app server and your database server. Again, I can go on forever, but that's just an example. Just remember your servers where your website is hosted, and the server will have installed web servers like AAS, Apache, etc. Right? I have another 5 minutes, so I'm going to make this as quick as possible. So if I'm going back to high performance, right? We also talk about um, multi-threading, right? Applications, right? When we talk about two CPUs, and these applications are designed to use multiple threads, and these application examples would be like a Java app or a development tool, right? And these applications are meant to perform better with more vCPUs, right? Then we also have something called background processes, and that's like within your task manager, right? And that's important to note too. So essentially, if your VM runs background services or just a scheduled task uh, beside a main application, or even daemons, I don't know if you guys heard of daemons. A second vCPU prevents slowdowns due to any conflict from your CPU resource, right? Lastly, when is a vCPU um, when is one vCPU enough, right? And this is a misconception that a lot of people make, right? So, you have a lightweight machine, and that's like your basic Linux server, your DNS server, your DHCP, your file. That's when you need one vCPU. Any test environments, any development environments with low input output or CPU needs, you have a single user logging in or just using it, or an idle VM, right? That's on. You'll need that one vCPU. Any other over provisioning of a CPUs can lead to conflict, right? Or worsen across your VM. So be sure that if you're unsure, monitor your CPU usage, right? Inside your VM, like your task manager. It's important, right? So if your CPU exceeds, and this is I tell a lot of people, if it exceeds 70 to 75 or 80%, it's a sign that you might benefit from 2+ vCPUs, right? So more vCPUs don't always mean better performance, especially if your host machine is overcommitted, right? So I want to thank you guys again for joining me in the session, and look forward to hearing from you guys soon. Take care.